So in this video, let's talk about what takes a database down. What do you mean? Like, what do people mean when they say that the database is down? What are quick short-term solutions to get your database up again, which means get your applications up once again very quickly by minimizing the downtime? And more importantly, what should be the long-term fixes that we should be doing in order to ensure that a database does not go down again for the exact same reason. Right? So let's jump into the first one. Okay, what takes a database down? So a very typical structure over here, like a very typical high level diagram that we all have seen multiple times, is that you have your set of users sitting over here. They all connect to a load balancer. So whenever a user fires a request, let's say, hey, I want to load my feed or I want to log in, the HTTP request comes to the load balancer. Load balancer forwards the request to one of the API servers. The API server then makes a query. Let's say if we talk about a very simple SQL database, so API server will create a SQL query, will fire on the database, will get the response and send it to the load balancer. On load balancer will send it to the users. Right? So this is a very typical flow that we all have seen numerous times. Right? Here, one very peculiar thing, if you look very carefully, is we have taken care of scaling of our API servers. Like for example, if today, let's say today we have two users, and if we only had one API server, then that would have worked fine. But if the number of users increase, we would want to horizontally scale our API servers, which means more users, you want to automatically add more API servers into the scheme of things. So to do that, we have load balancers, auto scaling groups in AWS and whatnot to take care of that, which means we have horizontally scaled our API servers. As in, more number of people, more number of requests, you would be horizontally scaling up your API servers. So that is taken care of. But now if you look very closely, your database is intact. Like your database might not scale up. Like you do not typically on demand scale up your database, like depending on the traffic, you scale it up and then bring it down, because it's not that easy. It's not that operationally easy. So that's where the problem rises. If you suddenly see a spike in your traffic, which means, let's say someone very famous tweeted about you or your product, it will garner a lot of attention to it. So like you might see a lot of users immediately flocking onto your website. So this is that particular duration where you see a spike in the traffic that you are receiving. Now, what happens when then? Like let's say you're having a very good normal day and you suddenly see a spike. Let's see what happens in this architecture for that. So all the requests of all the users coming in after the tweet that a famous person made about you, the traffic will reach load balancer. Like all requests will come to load balancer, and your load balancer like you have horizontally scaled your API servers. So even if large number of users flock into your website, the API servers will scale it up. So your API servers can handle the incoming request that comes to it. Like no matter how large number of requests would come to it, your API servers are configured to be horizontally scaled. But now, if API servers become very high, like if basically there are very large number of API servers, what happens? Like they are ready to accept the traffic, they will accept the traffic. But what about your database? Right? All of this, every request that comes to our API server will translate into at least one SQL query that is going to hit your database. So even if you have horizontally scaled your API servers, your database is that one stateful component that is not that easy to scale up on demand and scale down on demand. So that is where the load on your database increases. So with such spikes, you have configured your API servers to work just fine. They would horizontally scale up. But your database, because it is that single point, not really a single point of failure, but it's that one stateful component that is not that easy to on-demand scale up and scale down, will suffer. It takes time for your database to scale up. So when you see sudden spikes, that's where your database goes in trouble, and which takes the system down, which takes the database down. So there are few possible reasons on what exactly happens when a database goes down. So we'll basically touch upon that. So when there is a sudden spike in traffic and your database is affected, so your database is not able to handle that much of load. Right? So your database goes down. Now this is the time when everyone is tensed. Arey, your database is not working. Arey, what would happen? Arey, my users are not. Arey, we are not able to accept payments. All of that thing. So it's a very tense moment on how to get your database back up again very quickly, because every single minute of downtime is costing you business. So that's where it's a situation of panic. Or what should we do to get it up again as soon as possible? So this is getting your database up again is your number one priority at that moment, and you have to do it as soon as possible, because every minute of downtime costing you business. Right? So let's see, what do people mean when they say database is down? You know what exactly happens when people say database is down? So first possible thing is your queries are taking very long time to execute, very long time. So when you say queries, like your request came to an API server made a SQL query, and if there are if far too many queries hit your database has limited RAM, limited CPU, limited disk to play with. So which means that because it's that one stateful component, it has a limited capacity. If a lot of requests comes in at that same time, it might take your database to run it might take time for your database to execute, to complete the execution of the queries. So like let's say 2 queries your database can handle very well, but what if there are 2000 queries? So database it will take time for your database, your threads on the database to evaluate and compute the results and then send it to the user. So that is where your queries execution will take time. Second, your API servers are not able to create new connections. So when people say database is down, it might also be possible that your database, when it's getting, when your API server is trying to reach out to your database is not even accepting a new connection. So because hardware is limited, you can only accept a certain number of connections onto your database. So if you receive more than that, your database will not even accept the connections. So that also could happen, that you have large number of API servers and API servers are not able to even create new connections onto your database. Third possible reason is your database server is continuously crashing. Like you would see that your database up, but it is constantly crashing, and you can see it in the logs on what is exactly happening on your database server. And you might find your database server is continuously crashing. This typically happens when the disk is getting full. That your database is booting up, but there is no place to store the data. Your disk is full. So that's where basically this is the most common reason why your database continuously keeps on crashing. Right? So there is either some sort of file corruption, or basically some sort of file system corruption, or it is because of very low disk space, that database is not able to write anything onto the disk. Right? So in order to, now if we jump before we jump into short-term solutions and long-term solutions, one very key point that I would want to highlight is you need to have a very exhaustive monitoring on your database. Very exhaustive. Because if you do not have an exhaustive monitoring, you won't know what happened. In order to fix your database, in order to get your database up again, you first need to know what happened. If you do not know what exactly happened, what would you fix? If you do not have exhaustive monitoring, you might just restart your database. That's the ground zero of your solution. Don't do it. So unless you are sure that, hey, this is something that would help me get my database up again. So that's where you need to know what is wrong with my database on the first place. What is the root cause of it, and then solve it. Right? So that's where you need very exhaustive monitoring into understanding what has happened. Right? So let's talk about a few short-term solutions that would minimize the downtime and would get your database up again very quickly. So one possible reason of your database going down is because the connections have maxed out, which means that because of the hardware that your database has, it can only accept a certain number of connections. A certain number, it may be 100, 200, 10,000, 20,000, 50,000, 1 lakh, something. But this number is fixed because more than that, it cannot even create TCP connections on that machine. So your connections have maxed out. So when that happens, it means that your API servers will not be able to create new connections onto your database. Right? When your API service is not able to create new connections onto your database, so how, like, even though you have accepted the request from your users, it is not getting executed onto your database. So yeah, like your user will see 5x6, some error, or worse, timeout. After, like, let's say a minute, they would say timeout, ki it could not get anything out of your database or as part of your response. So when this happens, connections max out, the first thing that you should be doing is to go and check which are the queries that are running on my database from a very long time. So here the trick is, you'd say, Arey, the connections are maxed out. How will I able to create connection onto it? So that is where there is something called as a root user, through which if you connect, so root user is always given priority to connect onto it. So in most databases, there is a separate set of TCP connections kept unused so that root user can connect to the database. Like, even if your normal user are not able to do so, root user will be able to connect to the database to solve this exact same problem. So through root user, log into your, let's say if you're using MySQL, log into the MySQL, through MySQL console, log into your database, and then find out which queries are running from a very long time. So show process list is a very famous command to do that. There are a few others, but show process list is typically the one that you should be going for to find out, hey, which are the queries that are running for a very long time, which means those are the queries that, because they are very long running queries, they have hogged up those CPU, they have hogged up those TCP connections. So you have to kill them. As soon as you kill them, a lot of short SQL queries will come and solve, will come and execute themselves and basically get the response and go away. Right? So killing that queries would free up those connections for other short-term, for other short-lived connections to create and execute and send a response back. Right? But if you have persistently seen this, like connections maxed out, anyway your database is not operational, it's down, like it might be partially operational, but in that case, one other way, like if the traffic is genuine and you want to handle that traffic, one very quick thing, although it requires a downtime, is to quickly scale up your database. So let's say if you're using a managed service, let's say by AWS, like AWS RDS, you can quickly go and scale up your database and basically make it 2x of the size. If you're using 4 GB of RAM, make it 8 GB of RAM, double the CPU, whatever the configure is, double it. When you do that, although it requires a database reboot, but you're sure that you'll be able to handle those number of connections. So if it's genuine traffic, scaling up your database might not be a bad option because you want to handle it. It's a very quick and hacky fix that you can go out when you have a max connection, but then you need to be sure that, hey, I'll be seeing these number of connections continuously over some time. That's where you would want to scale up your database very quickly. Another short-term solution for another problem is CPU operating at 100%, which means that your CPU has maxed out. Few possible reasons to solve that problem. Like this, first of all, you need to have a monitoring tool in which you see, hey, array, CPU is basically constantly 100%. So when you know that CPU is constantly under 100%, which means that even though your database can accept large number of connections, but there is no CPU cycles to execute it because the wait time is very high because there are far too many queries that have come in, and you're able to handle the connections, but you're not able to execute the query. So that's where your CPU is operating at 100%. And few fixes for that is, first of all, killing the queries that are running for the long time. Same solution there for the connections maxed out, same solution for CPU maxed out. So why would you, like, when you kill a query that is running for a very long time, what would happen? The queries that run for a very long time, because query execution typically requires a lot of CPU cycles. Obviously disk IO is there, but you will require a lot of CPU cycles there. So when you require CPU cycles to solve that particular, so to execute that particular query, what would happen? If a query is running for a long time, and if there are such queries that have either taken lock on a database or are basically constantly hooked up and are very CPU intensive, kill them. It would free up your CPU to do something else. So now not just pick any query to kill, but find out which queries are non-critical, which can be killed, just kill them. And more often than not, it's one of the recent deployments that would have triggered this. Like, check if any recent deployment was done that led to a push of a very inefficient query which is getting executed onto a database. Maybe a few joins here and there which were not needed. Maybe very poor indexing that might have done on your database. Like, you might have written a query that, or someone else might have written a query which is literally scanning the entire table every time it is executed. Very stupid query that is written. So revert those changes quickly. Identify if there was any deployment that was done and revert the changes very quickly. Then third, reboot the machine. It always works. To be honest, if you are very clueless, just reboot the machine. If you know that you do not need to scale up and CPU should not be 100%, just reboot it. It would take a couple of minutes, but at least you'll be able to minimize the downtime, and you might see another hiccup, but it will buy you some time. And if you see a consistent usage of, let's say your CPU was always around 80% and now it has hit 100% where you are not able to execute it, that's when, now that since you have seen consistent usage of CPU, that's when you decide, hey, now it's time to scale the database up, right? So permanently scale the database up for that. Right? So these are some very quick short-term solutions that you have to look out for. You would see a lot of similarities, but these sort of hacks and these sort of tricks are required to minimize the downtime. We are not solving the problem for the long term. We are only minimizing the downtime so that our business is back up again. Because obviously people should be using the product. Like infra cost comes the second. Your usage and your payments and other part, your business is more critical than that. So you would always want your business to thrive versus thinking, I don't scale up because it will cost 2x money. Business is more important there. Okay. Now that we have seen short-term solutions, let's move into long-term fixes for that. So now you have fixed your database. Everything's fine. The next step is you need to ensure that your database does not go down again for that exact same reason, right? Find and fix those things permanently, forever, right? Otherwise, your SRE team, your DevOps team will be just sitting there solving that problem. That same thing went down, and you'll be fixing that same thing, involving into your application teams into that to debug that issue and whatnot. You would want to immediately start working on the long-term solution for that to ensure that your database does not go down again for the same reason. There might be other reason for which database is going down, but at least for the same reason it should not go down again. So let's say, first of all, what we should be doing is ensure that the right set of indexes are in place. This is the most common reason that I have seen your database operating at 100% CPU. Like, if you do not have the right set of indexes on your table that you are querying, let's say you have a blogs table and in which there are 1,000,000 blogs written, and you want to fetch all the blogs written by a particular user. So you will fire a query like select star from blogs where user ID is equal to 1 to 3. So when you fire that query, if there is no index on user ID and you have 1,000,000 blogs, every time this query is fired, it will have to scan the entire table. So scanning that entire table will require a lot of disk IO to be done, will require a lot of CPU cycles to be executed. So query execution time will increase. So that's where ensure that you have the right set of indexes in place, because if you had an index on user ID for the table, the query execution would have taken milliseconds, if not microseconds, to do it. So audit the queries and see if you have the right set of indexes. That's where you need to monitor the queries that are taking a long time on your database to execute and see if it needs indexing of some sort, and do that. Second, check the database configuration parameters. So every database has some boot up configuration parameters. For example, here I'm taking example of MySQL, but every single database has some very similar flags that you pass in when you boot up the database. So if you are on AWS RDS, you would have seen a parameter group. This is that. So there are few database settings that these settings come out of the box of database. They have some default value, but that value might not be relevant for your use case. For example, I'll talk about a few of here. So here I've listed 5 that I've seen in my personal experience, that these 5 were the ones that if I changed, my database performance shot up, right? So first one is InnoDB CMP per index enabled. This is InnoDB, like for the MySQL storage in InnoDB, the compressions per index enabled. So by default it's true. You need to, I'm not sure if by default, well I forgot about it, but you need to check if you really need compression on index, what happens if it is compressed, what happens if it is not compressed, and see if you want to tune that parameter. Second is commit concurrency. So InnoDB commit concurrency. It says that how many threads in parallel can commit at the same time onto this database. The max value I think for this is 1000, right? But if you'd want, like, what's your current value, what's the value that you desire to have, and what kind of impact would it have? Like, you need to load test and test key what is the impact of changing this parameter. The third one is the most interesting one, InnoDB flush log at transaction commit. This is something that violates ACID properties of your database. So what flush log says is that whenever you make a commit, should you be flushing the commit log immediately or every 1 second? Like, there are settings like 0, 1 and 2, but what it says is that if you want to synchronously commit the, if you would want to synchronously flush the commit log that has made, that was just done onto your database, onto the disk, right? So the commit happened onto the database. Do you want to immediately flush the commit onto the disk? If you do so, then every commit that happens onto the database requires a disk write, right? Because it is immediately flushing there. So that is where, if you do not want to have that sort of guarantee immediately flushing it, and you are okay losing out on some data, right? In most cases it might not be possible, but if your database is not going down that often, you can still do that. So if you want to set the flush frequency to 1 second, so for 1 second it will bulk up, it will put it in the memory buffer, all the things that needs to be there in the commit log, and then it would flush it. So flush on the commit log happens every 1 second, which means for that 1 second you are not doing any disk IO. It frees up your database to do something else. So to handle large number of traffic, you might want to evaluate, hey, should I have, like, what should be my flush frequency? Should it be synchronous or should it be once every second? Then similarly, there is flush method and there is lock wait timeout. So lock wait timeout is an important one, where you say that how long should my transaction be waiting on a lock, right? Which is like on a lock of on a particular set of rows. How long should I wait before I timeout? So this is important one, because if you have a longer wait timeout, so which means your transactions will be waiting for a longer duration for a lock, and then it will time out. So let's say if it is 1 minute. So for that 1 minute, that one TCP connection for one client is waiting, which not only gives poor experience to your user, but also hogs up that one TCP connection. So you might want to alter this parameter and set it to something that you desire for your application. You know, how long should it wait? If it's too short, then your client will see very quick error, hey, I'm not able to execute it. So it should sit somewhere in between, but it totally depends on the application or the service that you are writing. Okay. The next point is checking for notorious n+1 queries. This is a very, very interesting one, because we all are recommended to use an ORM to connect to the database. So ORM comes up with a particular set of issues of their own, because although it makes life simple for everyone, but it has its own set of issues that it comes with. So n+1 is a very notorious query. You should definitely check out, you should definitely enable logging onto your database to check if you suffer from n+1 query. I will just spend few minutes to talk about what exactly is n+1 problem. So let's say you have two tables, you have blogs and you have users, and every blog has one, or let's say every blog has one author. Right? Now let's say you are rendering 10 blogs, like, and when you are rendering 10 blogs, you want to fetch the details of the 10 authors of those blogs. So how would that query look like? You would first, like if you are using a very raw ORM, your ORM will fire query like select start from blogs, limit 10. Right? And then for each of that blog, it will fire one query to get the author ID of that blog. So select start from author where ID is something. So if you fetch 10 blogs, then the next step would be your ORM will fire 10 different queries to fetch details of every user separately. Right, so this is a problem of n+1 query. So n, like you fired one query which brought you 10, and then you had to fire 10 queries to fetch the next set of details. Right, this is a classic n+1 problem which could have been solved with joins, prefetches and whatnot. So whenever you are writing a query like whenever you are using an ORM, you need to check how many queries is one ORM firing in order to resolve that particular object, right? So blogs, within that blog's author, if you are fetching n blog, if you would want to render n blogs into it, how many queries does it translate to? So enable, like in your development environment, enable the query logs on your ORM and see if you suffer from an n+1 query problem. It's a very famous and it's a very notorious problem, but solving this improves your database performance by a huge margin, and it ensures that your database is operating efficiently. The next, last few things, the next thing is upgrading your database to a newer version. So a solid example, like as a long-term fix, let's say you are using, obviously it should not be always database upgrade, but and it's not that easy to upgrade either. It's a very long-term thing and it's a very big project, a database upgrade, a database version upgrade. So, but if you are using a very old version of your database, obviously it's not as performant as what it used to be. Like it's not as performant as the latest version that has been rolled out. So an example of that is, let's say MySQLite. Let's say you are having issues with replication, your replication lag was very high. So let's say you are using MySQL 5.6 something. So you know that if your issue is with replication lag, you need faster replication. MySQL 8 gives you faster ingestion rate for replication so that you can ingest your data faster. So earlier, let's say this is how your master and replica used to replicate with like few threads, not so performant. This suddenly gets enhanced because it has a very fast replication. Now it supports more thread in concurrent, basically more threads concurrently to answer this, to basically take care of the replication, which means very fast replication you will get. Right? So there are a lot of nuances to take care of, upgrades are not easy. It requires a lot of cross team efforts and whatnot, but sometimes it is worth to upgrade your database to the latest version to gain that sort of performance. So it might be one of the potential long-term fixes. Right? And the final thing is evaluate the need of horizontal scaling. Right? Like you might just have one database in your system, but if you have seen a spike, evaluate if you would want to have read replicas for your database and move a bunch of read loads onto read replicas versus only master handling all the thing. Let master only take care of the writes and not worry about the reads, right? And let the reads be sent to read replica directly from the business logic so that your master is free to handle writes. So that's where to handle more read load, you would want to add more read replicas, right? But if let's say you have large write load and you already had read replicas to serve read, but to support more writes, it's not possible to go beyond a certain hardware size of your master. So that's where you might want to partition or shard your database and create two mutually exclusive set of shards to handle it, to support more write load, such that every request for a particular set of user always goes to a particular shard, right? So each shard is an exclusive set of data. Like let's say you are creating two shards, half the data resides with first shard, half the data resides with the second shard. In the business logic, you can handle key if the hash of user ID mod 2 is equal to 0, move it to the first shard. If it is 1, move it to the second shard, right? Something around that. So this is typically the last stage of scaling on doing multi-master or doing sharding on your database. You might not want to do that, especially on the SQL load. but at least till read replica, offloading the read request at least would help you solve the problem in a longer run. Add read replicas, move more critical reads to your read replica, and let a master be free up to handle writes and very critical reads. Right? Oh, nice. So these were few long-term solutions that were critical that I've seen in place that solves a problem for a very long time. So yeah, that's all for this video. Now I hope you have a very solid understanding of what happens, like why database goes down, what happens when database goes down, few short-term solutions and few long-term solutions to help you solve that problem in the longer run. Nice. Chala. So yeah, that's it for this one. If you guys like this video, give this video a thumbs up. If you guys like the channel, give this channel a sub, and I'll see you on the next one. Thanks.